Hello, everybody. Welcome to this Mathigon webinar. My name is David Poras from Mathigon. I'm really excited to have you all here tonight. We are going to start it in a minute or two as you are getting settled in. If you want to go to the link on the screen to find the links for tonight, mathigon.org/pd/ELEM, it'll bring you to a page that has all the links for tonight that I'm going to be sharing, including this one to a puzzle a day. And so in this puzzle, you are trying to move all the pieces onto the board to cover up everything except March 24th. So maybe I could put this piece here and I could spin this one around and put it on there. You can flip pieces. Notice when I click on a piece at the bottom, there's a flip option. So I could turn it different ways to flip it if I wanted to. And so as we're waiting to get started, I'll start officially at 7:02. If you wanted to give this puzzle a shot, you can at this link, mathigon.org. It's in the chat, /PD/ELEM. And see if you, in the minute or two we have as we're waiting for people to join, see if you can find a solution. Again, the goal is to cover up everything except March 24th. Yep, the link in the chat is coming in a second here. It's also up here on the screen, mathigon.org/PD/ELEM. I'll get started in another minute or so. See if you can find a solution to this puzzle. Play around with it as we get going. Great. All right, I'm going to jump in. Welcome everyone to this webinar on using Polypad and virtual manipulatives on Mathigon. My name is David Poras. I work on the content side of things at Mathigon. I am a 6th and 7th grade math teacher in Weston, Massachusetts, which is outside of Boston. And I've been working with Mathigon for about a year now, and I'm really excited to share with you all the wonderful virtual manipulatives we have on Polypad, as well as some other features on Mathigon towards the end. The plan for tonight, I'm going to share for about 45 minutes or so. I'm going to run through things a little fast because there's a lot of wonderful things to share tonight. This is being recorded, and so in a day or two, you'll get an email with the link so you can watch it and go back and if there are any parts that you missed what I was doing, you can go back and watch it again. This puzzle of a day, a puzzle a day, is made by a puzzle maker in Norway. There's a link at the bottom to the actual puzzle. Mine came in the mail about a week ago, and my kids and I and my wife have had fun solving it. This is the solution to March 24th. I came home and my son had done this today. So I'm not going to give it away. You can come back and pause the video here if you want to, but I've posted this link in my Google Classroom for my students, and there's some that have really enjoyed doing it on a daily basis. It's also a nice activity when kids are finished with something or as a warm up or a do now or something. There are some days where there are more than one solution. I don't know if there are for March 24th. I found one. So I'm going to jump in, and in my tab here, I'm going to go to mathigon.org. All the links for tonight are at this website, mathigon.org/PD/ELEM. It'll be in the chat a few times. And so on Mathigon, there's all sorts of tools and activities and games. I'm going to spend most of the time tonight focusing on Polypad. So I'm going to click on Polypad here. And on Polypad, this blank white space, we call a canvas. It's where we do our work. And on the left here is a menu of tiles. And we can put tiles on the canvas to make all sorts of interesting mathematics. And so I'm going to start with the number tiles. I'll come back to the geometry tiles in a little bit. And the first group of tiles I'm going to start with is the number tiles. To put a group or a tile on the canvas, you can click and drag and put it on the canvas. You can click and it shows up on the canvas. So you can see there is a 100 block, a 10 block, and a 1 block. And in Polypad, anytime that you click on a tile on the screen, at the bottom of the screen here, a range of options are going to come up that'll change based on which tile that you've clicked upon. So in the number tiles, there's an option to split them. And so you see here, this right now is just a group of 100. I can move it around, I can spin it, I can change colors. But if I split it, I can choose any group that I would like to of the 100 and do things with it. I'm going to delete those 10. So now I have 90. I'll delete 10 more, so there's an 80. Here's the 10 block. I could do the same thing. I could split it up and get rid of 1. I could take this 1 and move it over here to make the number 81. And now when I highlight all of them, there's a merge option now. So I split them up, and now I'm going to put them back together to make a group of 81. And you can see it arranged the tiles into a different group. In addition to the menu options on the bottom, there are a lot of options on the right over here. So I'm going to click on the grid settings, and there's all sorts of choices for a grid background. I'm going to turn on this one, which is 5 by 5 grids. So I'm going to start fresh. I'm going to get rid of all these. I'm also hitting the delete key on my keyboard, and I'm going to build the number 50. So there's 10, 20, 30, 40, 50. I just clicked 5 times, and I'm going to merge them to make a block of 50. And what's really nice here, this black handle, as I click and drag this black handle, it's going to make rectangular arrays of the number 50. So as I move it in, we can see here's 5 times 10. If I slide it the other way, there's 2 times 25. We certainly know that 3 is not divisible by 50, but I can see here it's 3 groups of 16 plus 2. So all sorts of wonderful fun can be had with factors and multiples. Right here is, what do we have? 9 times 5 is 45, plus the 5 is 50. If we do 8 times 6 is 48 plus 2. And I might stop here with students, and I could split these tiles and make these 2 a different color. So there's a color option down here. Maybe I'll make these an orange or something. And then there's a pen option at the bottom here with the drawing tool. So I'm going to go to the drawing tool and choose blue. And you can see there's like the pen strokes, which is kind of thin. There's a marker, which is a little bit thicker. There's a highlighter, and there's a ruler to draw a straight line. So I might want to say here that this is 8 by 6. And then I could change the color to show that there's 2 left over. And then I could write something like this shows us that 50 tiles is 8 groups of 6 plus 2. Oh, 8 groups of 6. I was ahead of myself there, plus 2. If I were doing this in school, I would erase this and do it a little bit neater, but you get the idea. So all sorts of wonderful fun here could be had with number tiles. I could make a group of 11 and talk about what kind of rectangular arrays I'm going to merge them together. Can we make with a number 11? And we certainly know the only one is 1 and 11. I'm going to go to a new Polypad here. I just want to start fresh. So if I click here at the top and go to Polypad, it says, do you want to save these changes? I don't want to save these changes. I'm going to do discard. And so maybe I might challenge students to show all the rectangular arrays for the number 20. And so here's 20. I could turn my grid back on, and I could show 1 by 20. I'm going to copy this now, and lots of ways to copy things. There's a copy option down at the bottom. So I just clicked the copy option, and now I could drag it in and show 2 groups of 10. If I also just use the C button on my keyboard, it doesn't have to be Command C. I just tapped the C, it makes a copy, and then I could do 4 groups of 5. I also, if I click and drag, it moves it around. But if I hold down the Alt key, ALT, and click and drag, it pulls a copy off the top. So that's a really nice feature that I find myself doing a lot when I copy tiles. Again, if I click and drag, well, that copy ended up on top. If I click and drag, it just moves it around. But if I hold down the Alt key, it pulls a copy off the top. So maybe you could challenge students, what's the biggest number of rectangular arrays you could find for any number below 50? And they could be off and running and having a great time with that. The other number tile or number type I want to share with you next is the number bars. And this looks like the familiar Cuisenaire rods. Under settings on the right, there is the opportunity to go to the colors that you may be used to with Cuisenaire rods, the actual ones. So you could toggle back and forth between these colors and the alternate colors. You could choose to have the number labels on or off. And of course, all sorts of wonderful activities could be done with the Cuisenaire rods. I'm going to share a few examples with you right now. I think one of the great powers of the virtual tools on Mathigon that I've used a lot as a middle school teacher, and I think can be used across the span, is allowing students the ability to decide when they need the concrete tools to make sense of things and when they're ready to abstract the ideas and no longer need the physical tools to help them with concrete understanding of things. So I'm going to share an example with you. I might say something to students like, find the sum of the numbers pictured below. Numbers pictured below. And I'm going to add a couple problems on this canvas and then show you how I would share this with my students. So maybe my first question would be with number tiles. So I might give them a question. I'm going to split these. I'll make this 8 plus 7, right? So I'll put 8 and 7 up here. I might make the 7 a different color just so they can see the two numbers a little bit more clearly. And then there's a number line option. So I'm going to put the number line on the canvas. And as I move up the number line, you can see that the 8 is matching up with the 4. That doesn't seem right. But you might have noticed that when I click on the number line, a menu for the number line pops up on the screen. So I don't want this width to be 2. I want the width to be 1. So there, now it matches up, and maybe I'll extend it a little bit based on the problem that I've made. So there's one problem with number tiles. Maybe I'll put one more on the screen, maybe 10, a 10 frame I'll give them, and then get rid of a bunch of these. Oops, get rid of a bunch of these and have them do that addition question. I'm going to copy the number line. I just hit the C button on my keyboard. So if they want to use the number line, they can. Maybe I'll move it down 1 to give them a little bit of space. And then I could ask some questions with the number bars. So maybe I'll do 8 and 5 over here. And then maybe I'll give them a 3, a set of 3 number bars, maybe a 3, 10, and a 2. And again, I can highlight both of these number lines and copy them and then move it down here. I'm also using the arrows on my keyboard. And then what I think is really exciting is this question builder feature. So I'm in a teacher account. All of this is free. Every teacher account is free. Student accounts are free. It's free to all users. You don't need an account just to go play on Polypad, but this question builder feature is only under teacher accounts. And to assign it to students, your students need a free Mathigon account as well. So this, it says preview here. What that means is it's available to all users under a teacher account. It means that it's a limited amount of features right now, and we are working behind the scenes to add more features to the question builder. It works, it's ready to go. The preview just means that there's more coming. So I'm going to put a blank text box on the canvas for each one of these questions. And you can see right now it's just a blank question mark. And on the teacher side of things, I'm going to put the answers in here. So what do we got? This is 15. 10 and 3 is 13. We've all had a long day teaching, so if I mess up here, you can let me know. There's 15. This was not a good example to make as a teacher. 2 of them were this, there's pairs of answers here, right? So if I were actually doing this, we might want to mix up the answers a little bit, but that's fine for tonight. So now I'm in tiles here. This is where I've been working under tiles. At the top here, there's a library option. So I'm going to click on library, and I'm going to save this Polypad. Again, you need to have an account to save them, but it's all free. And I'm going to call this addition practice maybe. All right, so I'm going to save this and I want to assign it to a class. So I'm going to leave Polypad for a second to show you some of the teacher features. So under my account here, when I click on this little person made out of tangrams, I'm going to go to my teacher dashboard. So I'm going to open that in a new tab. And you can see in my teacher dashboard, I'm in my Mathigon account here. I have a sample grade 7 class. In my actual Mathigon account for the school district that I work on, it's a different Google account. You'd see all 5 of my classes here. But I'm going to make a new class. I'll just call this Elementary Mathigon class, and I'm going to create it. And then I want to add students to my class. In the school district that I work, we are a Google Classroom school. So when I did it with my students, I just clicked import from Google Classroom. A menu of all my classes came up. I picked it, and it automatically imported all the students. But for tonight, I'm going to use this code. So I'm going to copy the code, and then I'm going to go to a different Chrome window and go to my daughter's Mathigon account. My daughter is named Emily. She's in 2nd grade. And so I go to her student dashboard, and it says add new class code. So I'm just going to paste in the class code, and then she's going to join the class. And so there it says David Poras is her teacher and parent, actually, right? She's both. And the school that I'm in on that Mathigon account, I just called Mathigon Middle School. So now she's in that class. I'm going to go back to my teacher account, and hit the reload. And there she is, Emily Poras, the only student in this class right now. So I've made a class. I have a student who joined it. I'm going to go to this Polypad that I made, right? This is the one that I just made and saved. And now I'm going to go to the class tab, and I want to assign this to her class. Notice this is the grade 7 class. She's not in that one. She's in, let me do a reload. And there is the class I just made, elementary Mathigon class. So I'm going to assign it now. You've shared this Polypad with your class. There's other ways to assign canvases, right? So let me just pause here before I go back to her account. Here's the share and embed option. As I click that, it's slowly coming up on the Zoom, but there's a way to post it to Google Classroom. There's a way just to get the link and copy it. That'll probably come up in a second, but I'm going to go back to my daughter's account and go to her Polypad now. So now under her Polypad, these are the tiles. She's not a teacher, right? So just to point out, there's no question builder feature because she's not a teacher. There's no class feature because she's not a teacher. She's under a student account. But if I go to her library, there is the assigned canvas. And so when I click on that as a student, I'm going to just click on library to get it out of the way. These are the questions with question marks, right? So what I like, which back to this idea of when students are ready to move from the manipulatives and the concrete to the abstract, she's now here as a student. She might take these blue tiles and move them on the number line, and then might take the red ones and move them on the number line and see that the answer is 15. And when she types 15, she gets a green check. And maybe she's feeling confident now and she's like, I can just picture this. I can picture 10 and 3, and maybe she thinks it's 12. Oh, she got it wrong. It's not 12. Maybe I actually need to move these down, right? Because she got it wrong. Now she's incentivized to use the tools. That's 13. And then 8 and 5, she might not want to move these down, and she might know that that's 13. And this one she might know without having to move them down, or maybe she will. Maybe she moves those down to see that it's 5, and then enter in the answer of 15 here. And when you get them all right, confetti comes down on the screen to show that you got all checks. Right, so now what she needs to do is save a copy of this canvas. So she saved it. And now on the teacher end of things, when I hit this arrow, there's her canvas, right? So if I click on her canvas, I can see what she needed to do to help think about these questions, right? So I can see as her teacher, she took the models and used them on the number line to make sense of what was going on. Here, she didn't need to bring down the 10. And I found as I look at student canvases on these types of questions, again, it's middle school, so the actual questions are different, but the idea is I'm getting great insight into who was ready to abstract the ideas and who still needed the tools. I can see she got them all right. This green and orange means that there were some questions she got right after multiple attempts, right? So as you recall, this 13, she didn't get right the first time. If there was a red one here, there might be a question she was not able to get correct, and that would be red. There's data that I could download into a spreadsheet. I could turn off her name, right? So if I'm sharing this with the class and there's 20 students here, and there was one interesting example that I wanted to share, I could pull it up on the screen and not have the student's name, which is a nice feature. So now if I'm done with this as an assignment and I unassign it, on her account now, when I do a reload, you can see here, it's a saved Polypad of hers because she saved it, but it's no longer there under her assignments. So when you get rid of an assignment, it goes away. So I think that's a really powerful tool. I'm going to share a number of examples tonight about how you might use this question builder and assign canvases to get insight into your students' thinking. All right. One other idea on the numbers that I want to share with you. So I'm in my library now. I'm going to do a new Polypad, and I'm going to go to tiles, and I'm going to go under algebra. I know we are an elementary crew tonight, so I'm not going to dive deep into algebra tiles, but there's a scale here that I want to share because I think this is a really powerful tool for students at all ages. And I go back to numbers, and I can put number tiles on the scale. So I'm going to put down 10, and that's going to weigh down that side of the scale. When I put a 1 here, it's not going to balance it out. If I put a 10 over here, that's going to go down. But then I can add a number bar of 1 to make it the same. I could add maybe a 4 and a 5, and we see that all of these number bars and number tiles work together on the canvas. And I think a great feature of Polypad is the ability to create canvases that use tools from all of these categories. And so in the links for tonight, which is in the chat, mathigon.org/pd/ELEM, will bring you to this site. And here's an example of an assignment that I thought could be good for, first, second graders as they're making sense of balancing and equality. So this I could assign to a class. So I'm going to assign it to my daughter's class. I'm going to go to her account now and hit reload. And there's her assignment. And this assignment says, add number tiles or number bars or number cards to balance the scales below. So you can see I've added these number cards here, which we haven't talked about yet. So under numbers, we have the number tiles, which we've seen. We have the number bars that we've seen. And then there's number cards, which is a card with a number on it. So this looks like 10 and 3. So if I put 7 on this, it should balance out. And it does, right? And what great feedback for students in the moment to see that they balance the scale. It's another version of the question builder where you get the immediate feedback, right? This looks like 23. So I could do it with number bars. We could put a 10, right? All of these balance out the scale together, 23. I'm going to stop here. You kind of get the idea, but I think this helps kids see different representations of numbers in lots of different ways. On these number cards, if you put them on top of each other, it makes 17. So they could combine those to make 17. And then if I go to the number cards and pull out an 8, I think that's 25, then I could put them together to show that that's 25, right? So she could save it again. She saves it. I go to my teacher account, and then I could share that with the class. And I'm sure students would have solved these lots of different ways, right? I chose to do the number bars to make 23. If this were a class, we'd probably have a whole bunch of different ways to share, and this would be really nice to do with names on or without names on. I saw on Twitter recently, it's great to see some familiar names in the webinar tonight that I've gotten to know over Twitter over the past couple of months. There was a teacher that was doing a paper version of this. And so I just made a Polypad version. So there's dice on the screens. I'll get to the probability tools later on tonight. But when I click the dice, there's a randomize button at the bottom, which spins the dice. And the activity that she was doing with students was using the Cuisenaire rods to build that number. So 116. And then she had students build the same number with a different set of bars. So maybe we could do 3, what do I got? 8 there. So 3, 2, 3. And of course we could stop here and I could line them up and I could see that they're equal. I could put them on the scale, or students could put them on the scale to see that they're equal. I thought it also could be nice to use the number cards here to say, all right, I have a 1, and a 6. And if I want to check for equality here, I could do the 3, the 2, and the 3. And then students could put these together, right, to confirm that those are the same amount. So that was a nice way to do this activity that she was doing with, dice and rods, and to do this in a virtual space as well. All right, so that's it for numbers. We could spend all night talking about numbers. I just want to show you, actually, not quite yet all for numbers. I'm going to go to a new Polypad. Some things I'm not going to discuss in detail, but I just want to show you. There are these prime factor circles. If you've played the game Prime Climb, maybe 3rd, 4th, 5th grade, or which is made by Dan Finkel at Math for Love, a great way to think about prime factors. So these might look familiar to you if you've played the game Prime Climb. There's 18, and you may know that's the 2 times 3 times 3, the prime factors of 18. But what's really nice here is I could make a copy of 18, and I can pull them apart. So there's the 3 I pulled apart. There's another 3, and there I can see 18 is 2 times 3 times 3. I didn't need to make a copy of it. I just wanted to keep the original 18 on the screen. And I could put 24 up here and show that 24 is 2 times 2 times 2 times 3. We can put them back together to confirm it. I can take the 6 and put it up here. As a 6th grade teacher, when we've talked about prime factorization and greatest common factors, this has been a really valuable tool. I did a middle school webinar 2 weeks ago. The video is online at Mathigon. So if you're interested more about prime factor circles, go check that out. There's also a multiplication grid, which, a lot of websites have multiplication grids out there. What I think is really nice here is, this I can extend it in either direction, but we can also change it from a 10 by 10 to base 10 multiplication to other bases of multiplication. So here, each box now is 5 by 5. So there's a 25, here's a 5, here's a 1. We could go to base 7 multiplication. These are 7 by 7 boxes, which I think is super fun. And then in preview mode is the idea of exploding dots, James Tanton's work with the Global Math Project. I'm not going to do tonight, but super fun to play around with as well. All right, let's keep rolling along. Again, this is being recorded, so I know I'm going a little fast, but we will have, you can go watch the video later on. I want to jump to the geometry tools. And the first activity I want to share in the geometry tools is linked. Again, this is mathigon.org/PD/ELEM. There's the link to all of these. I'm going to share with you this pentominoes, area, and perimeter. I'll give you a tour of the geometry tools in a second, but this is, maybe 3rd, 4th, 5th grade exploring area and perimeter. I would share this with students. I also just want to show another way to share this. I've copied the link at the top. You could put it in a Google Doc. You could put it in Canvas and Google Classroom, any way that you share links with students. I'm now in my daughter's account. If I just paste that link at the top, it's going to bring me to this canvas, right? So I was showing you how I can share it within Mathigon, but even just grabbing the link and putting that however you share a link with students would be great. So this question says, or this, this activity, this shape is made up of 2 overlapping pentominoes. You may know a pentomino is made up of 5 squares. These are all the arrangements of 5 squares. Here's an outline of the shape. So students could count the area and say that's 10, and then they could go around and count the perimeter. And I think that's 14. So as a introduction to the activity, either the first time thinking about area or maybe a reminder of it. And then the actual activity is having them make their own shapes using 2 pentominoes and asking them to think about what's the smallest perimeter they can make and what's the largest. So maybe they would take this pentomino, I'm going to copy it to keep it there, and maybe I'll take this one. And students might be able to look at this shape and get the area, right? Or I would share with them how they could use the lines to trace the shape. Maybe they need to actually see the boxes underneath the shape. I'm going to finish this off here because I think it's a good example. Right, so I could do that and make the shape and then go down to the move tool and move these out of the way. And now students could go through and count and put what the area is. And then they could go around and count the perimeter. And so, again, their challenge for them is what's the shape they can make with the smallest perimeter and the greatest perimeter. And so just as a quick introductory activity about exploring area and perimeter, I think students are really motivated to think about how the shapes can fit together and then calculating area and perimeter. They could save it. And then as a teacher in your class, you would have all their examples you could share with the class easily. Who made a perimeter of, who thinks they have the largest, and go off and share that with the class. So that's super fun. I'm going to keep moving along here into the geometry tools. And I'm going to start with a clean canvas. I'm just going to go to Polypad at the top and go to tiles. And now I'm going to go to polygons. So all sorts of wonderful polygons here. I can take a square and put it on the screen. Here's a triangle. This little handle can rotate the shapes. And the shapes kind of snap together really nicely. It's like smart snapping. So as I move it together, they snap. I can highlight the shapes and copy them and rotate it. I'm going to build something here. So that's going to rotate like this. I could click and drag all of those and copy it. And so as I spin this around, right, I can connect it. They snap together really nicely. I'll make one more to complete this shape. Boop, it all fits in really satisfyingly. And then I'm going to take this hexagon and stick it in the middle. That looks really nice. And then we can have all sorts of wonderful geometric fun with this shape. I'm going to highlight these and copy it. I just click the C button and bring it down here. I'll make one more. I'm beginning to make a tessellation here, right? And then I could, I missed a little bit. I was off a little bit there, though, that I missed the snapping together. But as I rotate it, I'm not going to go back and fix it. I can highlight this whole thing on the top and copy it. And then I'm off and running, making my tessellation, right? And I think at all ages, there's all sorts of great math exploration, right? Sorry for the gaps here, but you could talk about how many hexagons are used, what's the ratio between squares and triangles, all sorts of great fun could be had. I also want to share as an aside here under library. So I'm in tiles. Under library, all the way at the bottom. So these are all my saved polypads in this account that I'm using tonight. But at the bottom in any account, or even if you're not logged in, remember all free, you only need an account to save things and share with classes. These are some examples of polypads that have been made. And at the bottom here, there's a link to some lesson plan. Sometime within the next week or so, we're gonna push out an update to this. It'll have a lot more activities and links to use in classes, but that's there as well, all right? But let me go to a new polypad and go back to the polygons here. All of these polygons, except one, but almost all of them are fixed, meaning you can move them around, you can spin them, you can change the color. There's a cut tool, which I'll talk more about later on, but I can cut that into pieces, which is really wonderful for so many reasons. But this polygon is the custom polygon. So it's this one with the white dots. And when I put this on the canvas, I can move the vertices around. This is a pentagon right now. If I click on a line, see how the cursor changes to a plus? That's going to add a point. So now I'm at a hexagon and a septagon and an octagon. That's super fun. If I click on a point, it gets rid of the point, right? So you can keep clicking to get rid of points. Ooh, that's kind of fun. If there's a shape that I really like and I don't want to mess it up, I can hit lock at the bottom. So now I've locked it, which means I can spin it, I can do all sorts of things with it, but I can't move the points anymore, right? So I could copy it, I could rotate it. Oh, I spun a little bit too much. I could put it on top, I could change the color. And you may know that any quadrilateral where you flip and rotate it like this makes a tessellation as well. So my students have had a great time with this, making all sorts of tessellations where you take this shape and copy it and fill up the plane with all sorts of wonderful copies of this. Super fun. I'm going to stop there, but I could do this all night, right? I'm going to do one more. I said I was going to stop. I lied. I can't help myself, right? It fits right in there. Boop, snaps together. So cool, right? My students have had a great time making all sorts of fun designs. And then you can change the colors, right? Maybe I want this row to be a different color and make all sorts of wonderful patterns. So that's super fun. I'm going to keep going through the geometry tools, right? One idea that I thought could be good for elementary students would be a visual pattern like this. I'm going to get the link and show it to you from a student standpoint. We do all sorts of visual patterns in middle school, and here's an example maybe of one for elementary age students where there's a pattern, and in the first figures, they just have to count the number of squares and triangles. So maybe it's 1 and 2, and you get the green checks. If I do one of these, oh no, that's wrong. I counted wrong. That's 2 and 4. And they could begin to see the pattern, right? And then this might be good information as students are working with this. Do they see the pattern, right? Do they know that's going to be 4? Do they know this is going to be 8? Or is it helpful for them to take this and copy it and move it over and say, what's changing from picture 3 to picture 4 is I'm adding one more onto it, right? And so they could build picture 4. And as a teacher, you could certainly decide if you wanted them to make the pictures, if that was something that only if they needed, and then have them make up a pattern of their own, right? So good integration, I think, of the geometry tools and the boxes here. In 6th grade, at the start of this year, we explored area and perimeter of two-dimensional shapes, which I know comes up in upper elementary as well. So I want to share with you what I thought was a really powerful use of the tools. Again, I'm on this website, and I went to this link here, rectangles, parallelograms, and triangles. And my students at the start of 6th grade, they certainly had a good memory of finding the area of a rectangle like this. If I was doing this with students that were much younger, maybe I'd go to the number tiles here and put some number tiles on the screen and have them use these to fill up the shape, right? You can just copy and fill up the shape. I think there's a lot of videos out there, some great animations showing this where you see squares fill up the shape. I think there's a big difference between students watching someone make a really wonderful animation versus having students actually do it, right? The brain connections that are happening when you actually do something, I think is really powerful. There were some of my students that were like thought that this couldn't be done, right? I've just tilted the rectangle. And then when they did that, they were like, oh yeah, now I can do it. But here's thinking about parallelogram. And the cut feature here was so wonderful because I had students in pairs talking about how they could find the area of this. Pairs, distance, right? Talking 3 feet apart or so. I think at that point it was hybrid, so they were 6 feet apart. But they were still talking to each other. And so they talked about, there were some that they took the cut tool and they cut this triangle right here and then moved it over, right? And I've done this for years. I'm sure we've all done it, but I do it on the whiteboard and I erase the thing and I move it over. Or I have paper and we rip it and it's kind of a mess. It's the same idea, but being able to do this on these tools, I think was really helpful. And then here on the red one, they had to rotate it and match it up with the grid lines and then cut it again. And then we could move it over here. Of course, what was also really nice is there were students that said, oh, there are these 2 gray triangles here. So this looks like a 2 by 8, and that's a 2 by 8 triangle. So they said we could just move this point over 2 and move this one in 2. And there's the rectangle. How cool is that? And then for triangles, right, they said, oh, that's just double. And they even just by clicking could see it's double, right? But if they wanted to copy it and spin it and then change the color, right, there they could see that it's half. But this was really exciting. I thought this was a super cool moment as a teacher. There were students that said, let's take this one and cut it down the middle, which was great. And then they made a copy of this, changed the color, rotated it around. Oops, I hit the wrong arrows. Moved it into place, and then they did the same over here. I'm going to do it even though I think you know where I'm going, right? And then they made it a different color, and they saw, so yeah, that triangle is half of that rectangle. I'm going to undo all of that and get back to the original triangle. And then there were students that said, yeah, but we also could just take this and copy the whole thing and change the color and spin it around. And then there's the parallelogram like I had above, but now we have to cut this up. And so they cut it like this, and we moved this one over here, and it was the same arrangement, which I think was a really powerful moment for them to see there were 2 ways to get to this same arrangement. So that's pretty awesome, I think, of the area and perimeter and the cut tool. I'm gonna keep moving on from the geometry tools. There's all sorts of wonderful things here. There's tangrams. There's a whole site on Mathigon with tangram puzzles. We've seen the pentominoes. They're tetrominoes as well. There's rulers and protractors, Penrose tiles you can go learn about. They're awesome, as well as column tiles, make fractals and tantrix tiles. I could go on this all night, but I said I'd stop at 7:45. It's probably going to be about 7:50 if you want to stick with me, and then we'll do questions because I want to show you fractions and probability. And then I'll stop talking, maybe. All right, so under fractions, there's the fraction strips that you've seen a lot. There's this black handle, like on the number tiles. If I extend it, it makes the fraction strip longer, and if I shrink it, it makes it smaller. So this is a good way, certainly, to show improper fractions and mixed numbers. Just like with number tiles, you could split them. I could split them up, right, into pieces of a fourth. Which is super fun. There's the fraction circles, right? So I could put a 1/6 on the screen and then maybe a 1/9, and I can spin it around and put it into place. And maybe let's add an 1/8 to that and spin it around, and then add a 1/4 and spin it around. Even just asking kids like, can you make this a full circle? I don't know. I'm just clicking these randomly, right? Is there one that can fill that up? What piece do I need? I don't know. Is the 7th going to do it? Let's see. I think that's too big. Oh no, did I do it? Oh no, I'm off a little bit, right? So just in and of that itself, great math going on and trying to think about what those fractions are. What's also really cool, I think, is this works with the scales, right? So I'm going to go back to this scale under the algebra thing and put some fraction tiles on here. So I'm going to put on, I don't know, 2/4. I'm going to go to my fraction bars here. 2/4 and a 1/5, right? And even before students have done any adding fractions, right? This is just like thinking about fractions. You could ask them, can you balance this out without using 4ths and 5ths, right? Just go have fun, go play around. Can you balance it out? And certainly, you know, a 1/2 is going to do it. We plus a couple 10ths, right? Oh, I'm moving the scale by mistake, but that's okay. There's a 1/2 and then 2/10ths, right? I got to slide that down and it balanced out. So awesome activity. I think just playing around with the scales and the fraction bars would be great. My students this year, you know, needed a good review of addition of fractions. It's typically something they do in the spring in 5th grade. And so they did some great work on it last year, but certainly the pandemic got in the way a little bit. So we did some good review of fraction addition. Here's a Polypad that I used for that. I have the whole fraction wall on the screen as well as a number line. The example that we started off with was, I think something like 3, oh, that's a messy 3, sorry. 3/4 plus 5/6. I'm gonna fix my 3, I'm not pleased with that. I'm gonna go to the eraser tool and erase my 3. Or I'm trying to erase my 3. Let me go over here. There we go. All right. Sorry. 3/4, right? So what I did is I put 3/4 on the number line and made 3/4, and then put 5/6 on the number line and 5/6, and very quickly asked my students to make an estimate. And as expected, a lot of them wanted to make an estimate of 1.5, which was great. Great first estimate. And so before we did anything else, I said, all right, what do we think about 8/10, right? Anyone think that could be the answer? And they all very emphatically said no, right? There's no way that the answer could be like 8/10 over here somewhere. And I was like, great. No one wants to just add across. They were like, no way. Wrote that on the board, right? Framed it, right? So when they make that mistake, we could go back to it. But there's no way that's right. So we said, all right, it's 1.5. But then what I think is a wonderful tool here, when I click on the number line, I can change the division. So I showed you earlier how to change the width. If I change the division from 1 to 2, now we can see it's more than 1.5. So now we changed our estimate and said, all right, our second estimate was something more like, there were students said 1 2/3, some said 1 3/4, some said 1 3/5, all sorts of good estimates, more than 1.5. And then we went through and kept changing the divisions. What do we think about thirds? That was 13, sorry. What do we think about thirds? Oh, it's less than 1 2/3. So we said it's got to be lower than that one. And we kept changing the divisions until we got to one that we were happy with, right? And of course, there were students that were like, put in 12. And I was like, I'm not ready to put in 12 yet. Right? There's fifths. 1 3/5 is a pretty good estimate. And then we saw sixth and, oh, not 16, I'm sorry. Sixth. And students liked that the 6, I'm going to draw a straight line here, was like right in the middle. And that confirmed their thought that 12 should be good. But I didn't let them go to 12s yet because I knew that when I typed in 7 here, some might think that was the answer if I zoom in, right? 7s is really, really close. And so it was 1 2 3, 1 4/7. So I wrote down, I was like, are we sure it's not 1 4/7? And of course, they didn't think it was because, oh, I'm on the wrong one. Where I wrote down 1 4/7. What do we think? And eventually, when we went through and got the answer and changed it to 12ths, right? We compared it to 1 4/7, and we saw the size of that sliver, right? We could go through and calculate the size of that sliver. Just to finish this off, when we got to 12 here, 12 divisions, there it was, matched up really nicely. And so I took the 12ths and I put it up here and I shrunk it down and we said, oh, 3/4 is 9/12. And I wrote that on the screen. I changed it to red. I copied it and put one over here and extended it and made that one blue to match up and rewrote that as 10/12. And then I put on the 1 bar. So we first wrote 17/12. And then we said, oh, that's 1 and I think I might have added wrong there, but you get what I'm saying, 1 and a whole bunch of 12s left over. So that was a great visual of fraction addition. And I had kids who kept using this. Of course, I made a Polypad with the question blanks so I could see which kids were using the tools and which kids had abstracted the idea. Great feedback for me as a teacher to be able to do that. I have an example here, which I'm not going to go through, of fraction division. There's some videos online and we're going to be posting some things to the teacher page soon about that. But I want to end with the probability tools and then share with you some games down here. So I think 6 more minutes should wrap it up and then I will stay on and take any questions that you might have. So I'm going to go to a new Polypad, which will be at the top here under Polypad, and go to the probability tools. And so there are dice that you can roll, which are super fun. There are coins that you can flip. There are spinners. So this is a uniform spinner, which every region is the same size, right? And so right now there's 5 regions. If I move this dot in either direction, I can change the number of regions, which is really nice. And then there's a custom spinner, which as you move the dot, it changes the size of the region. And if you click on that, it adds a region. If you want to get rid of a region, you can get rid of it. right? Which is really nice. I think what is awesome is how easy and quick it is to roll 100 dice at once. So here's a canvas coming up that has 100 dice on the screen. Of course, it's going a little slow, but it'll get there, right? I'm just going to make it. It'll actually be quicker. This is also cool to show you how quick it is. I think the zoom in my computer is not liking 100 dice, but I can put one dice on the screen and then copy it and move it over here and move it over here and move it over here. Let's see if that's loaded. There it is. There's 100. It eventually got there, right? So there's the 100 dice, and we could spin all 100 dice at once. And you could make a prediction as a class. How many sixes do we think are going to come up, right? And so to be able to roll 100 dice that quick, and imagine you have 24 kids in the room, all of a sudden you have 2,400 trials of rolling a dice. And you could have each kid report how many sixes they got, right? How many sixes out of 100. And you could list all those on the board and then make a graph of that or find the average of that. Certainly rolling dice is fun, right? That's great. But being able to get big data sets really quickly, I think is really powerful for kids. There's lots of sites out there that you can click like roll 2,000 dice and it'll make the graph for you as it's rolling the dice. But students don't actually see the dice being rolled. I think to be able to see the dice being rolled is really powerful for kids. Here's one that has 100 pairs of dice, right? So as kids get older and think more about the ways to roll two sets of numbers, this will load in a few minutes. There we go. That was quicker. Not a few minutes, I meant a few seconds, right? But here we could roll 100 dice, right? How many sevens do we think are going to come up, right? Super fun, all sorts of great activities. And then the final things that I just want to share are at the bottom here, all sorts of wonderful math games that like integrate a lot of these ideas. So this is a popular game. This one comes from Dan Finkel, Math for Love. I think on YouTube, there's one like this as well. It's the blockout game, or Can You Make 100, where you'd roll the dice. And I got 5, 5. So I have to make a 5 by 5 rectangular array. So I'm going to copy this. I could drag the points out to make 5 by 5. There we go. There's 5. And there's 25. And then I could lock it so I don't mess it up. You could have students add a text box onto the screen. I haven't shared with you text box at all tonight, but I could write 5 times 5 equals 25. I could click on the text box and make it bigger with the A's down here. So there's 5 times 5 is 25. And then player 2 would go, and player 2 could roll the dice. And I'm gonna get a different one, but there's 5 times 5 again. They couldn't do that, right? There's 5 by 1. I'll copy this and move it over here. Maybe they want to rotate it and make their 5 by 1 like this. They could choose a different color and go from there. And if you played this game, I think players keep going until they can't make a move, right? And then they count up how many squares they covered. But I think some fun extensions of this now that's on a Polypad is maybe you could say, if you're stuck, you're allowed to move one piece, right? Maybe if they're allowed to move one of their pieces, it can get them unstuck, right? Or maybe once they finished, they could say, can you move the pieces around so you could roll again and get a piece in there, right? So that ability to move these around is kind of opens the door up for some other games to play, which could be kind of fun. There is Save 20, another game on Math for Love, where you have these dice and you roll them and you do it 4 times and you're trying to get them to all add up to 20. So now I'm going to copy the dice and move them down here for my next move. And I'm going to choose to save the 4s, right? So I bring the 4s over here, and then on round 2, I roll these. And the goal is to try to get 20, but not above 20. So I'll move these down here. Maybe this round, I'll save the 2, maybe just as an example. And then I roll these, and I see how I did, right? Again, in class, super fun rolling the dice, right? But what also I think is a nice addition to this game is it keeps track of their moves really easily, right? And so students could go back, they could share this, they could save it. You could ask them, explain to me why you chose to save the 2. I see that you chose the 2 here. Explain that to me, right? Could be a really nice conversation to have with students. There is the Genius Square game, which is a great game. There's a great actual game of this at the link below, where you spin all of these. It's actual dice in the game. This is the last thing I'll share, and then I'll stop talking, but there's so much wonderful stuff, it's hard to stop. You spin these and you put these blocks where the spinner came up. So I got to put one on E3. So even just talking about how to find E3 is valuable for kids. And then I'm going to put the next one at D6. And you do that for all of them. And then the goal is to cover up the pieces, that the white squares that are left, with all of these shapes. So the black boxes go where the spinner went. And then you use these, you can spin them, you can flip them. You can't cut them, right? It's just those shapes. So that's a super fun game. Other games here I don't have time to talk about. You can go explore them. Don't Break the Bank is a great one. I skipped Cover Up. You might know that game as well. And then lastly, back on Mathigon, under activities, I'm going to go out of Polypad now. So in Mathigon, I'm going to leave this. Yep. This is my teacher dashboard. If you just go to mathigon.org, there are a whole host of other wonderful things to do. We've spent all our night in Polypad here. You might have seen the multiplication flashcards on with spaced repetition. So these again are in collaboration with Math for Love, multiplication by heart. You may know, oh, I got that wrong. There we go. And this is based on, if kids are doing this in their account, it'll save their progress. And as they get them right, there's a longer delay from when they see that multiplication fact again. So all sorts of fun, wonderful things can be had with multiplication by heart. Awesome. Thank you for listening to me for all this time. I don't think we lost too many attendees, so hopefully it was valuable. There is so much wonderful stuff that I could talk about, but I'm going to stop there. I know looks like we have some questions in the Q&A. Philip is the founder and CEO of Mathigon. He's been on the chat, so I think he hopefully has been responding to some of your questions. It looks like he has. I just pulled up the chat. He was nice enough to join tonight so that I could ignore the chat and focus on what I was doing. All right. So are all the links with the PD, LMN link within the Polypad library? They are not right now. Good question. So in Polypad, let me just answer this question. If you go to library, there are example ones here. Some of which I talked a little bit about tonight. Under lesson plans, there are some links to pre-made lesson plans on Polypad. Here's the pentomino perimeter ones that I shared. There's one about factors. There are some videos about how to share with Google Classroom. There's the video of the middle school webinar from 2 weeks ago where I talk more about middle school topics. But coming soon, maybe by next week, is going to be a thoroughly updated version of this page that will include all these links I shared tonight, as well as about 40 other activities for a range of ages with students. So coming soon, but for now, this link, mathigon.org/PD/ELEM, will be a live link. And so these are free to be shared and used as you like. All right. Can the tiles library be customized? Can I make my own tile set or rename polygons as regular polygons? Good question. So there is not a way. Let me go to a new Polypad here. I'm just going to go to a new one. If I wanted to save this, right, I could save it. So there is not an option to change the names of these, but there is an option to make a link that you could share with students that only allows them to show certain options. Or if you just wanted to have certain ones available to students, you could put them on a canvas and you could save it, and then you could share that link with students. All right. Do students need to have an account to access something you post on Google Classroom? No. So anything that you do on a canvas, you don't need an account for. If they want to save their work, they need an account. But if they have a Google account, when you as a teacher, yeah, I'm going to leave this. When you make a class, if you sync your class to Google Classroom, it automatically brings in all your students. And so that automatically gives them a Mathigon account. And then if you post a link in Google Classroom and they open it, they can log in with Google and then they can save their Polypad. So all of my students, this isn't my account that I actually use in school. I have all of my classes here. And as soon as I imported them, it automatically gave them a Mathigon account that they log in with Google. Is there a similar set of resources for older students? Yep. So this one is the middle school webinar, and coming soon will be a page of like 40 or 50 activities that are also designed for middle school and high school students. And also under courses, which I didn't even talk about tonight, there's a whole host of intermediate and advanced math courses that you could do with students. It's got great interactive elements that would be great for middle school and high school students. So I encourage you to take a look at that as well. Can this be used for homeschool? Sure. Yeah. So you as the homeschool teacher would want to make a teacher account. And then your students, you'd want them to make a student account. And all the features that I shared tonight could be done with a teacher and a student, right? So there is nothing here that would limit that. Oh, exploding dots. Yeah, sure. So let me go to Polypad and go to numbers and exploding dots. So if you've played around with exploding dots, you know that explodingdots.org has a whole host of interactive things with exploding dots, as well as the Global Math Project. So this is really like, again, when it says preview next to something, what that means is this is sort of like our beta version of it, and there's more features that will be coming soon. It's not as fully developed as some of the other features. So when I put a dot machine on the canvas, I can change the base. I'll make this base 3. And you see when I changed it to base 3, the boxes changed to the 1's place, the 3's place, and the 9's place. And the blue dots are the dots. So I put a dot here, I'll copy it. I just click the C button on the keyboard, and then I do C again. So there's 3. And if you've worked with exploding dots, you know that in a 3-1 machine, every 3 dots explodes to 1 into the next. So as I drag this dot over, it becomes 1, right? So if I undo that, there were 3 here. Currently it works where if you just drag 1, it'll explode any group of 3. So if I have 6 here, right, I like how I'm not making it the rectangular array, it's automatically arranging itself like that. So now if I drag 1 over, 3 will go away. Same over here. So I started with 9. So 9 base 3 is 3, 0. And then I can go once more, and that means 9 base 3 is 1, 0, 0. I can go the other way as well, right? Implode the dots by going like that, right? And they're also, when I click on the machine, there's an explode button, which does that automatically, right? So let me just show that again. If I move this back here and I move these all back here, instead of going like 1 dot at a time, like what I did, if I click on the exploding dot thing and then explode, it does that, and you can kind of like see it happening, and then annihilate. So an anti-dot is like a -1 dot, right? So here there's a -1 dot. Thanks, Philip. And then if I click on the machine and then do annihilate, it'll cancel out a positive dot and a negative dot, which is super fun. Awesome. I think exploding dots. Yeah, I think I've answered all the questions. Thanks for sticking with us tonight. Really would love to hear how you're using this in your classes, right? So a lot of these games that we've put together have been from examples that, that either I've seen on Twitter, teachers posting, other folks at Mathigon, teachers putting ideas out there. So, we'd love to hear how you're using Mathigon, or if you have an idea, but you're not sure how to make it work, please reach out. The more we work on this together, the better. Quick feedback. I used the 100 dice in an introductory probability lesson last week with fantastic response from students. Awesome. So great to hear. Yeah, I think as I've shared, I think students being able to see that many dice rolling and really make sense of what's happening and counting them, I think is really powerful. Yes, like using actual dice is fun, and there's great value for an actual tool, a Cuisenaire rod, a number tile. But I think for a lot of the virtual ones, there's a lot of places to add value that can go beyond what can be done with the physical. All right. Thanks, everyone. Great spending some time with you, and have a great night. Enjoy Polypad.